There are a lot of different storage solutions available today to the Windows Server 2008 administrator. Experts estimate that business storage will double every 2 years. With this kind of growth, you are assured that your business will always be adding more and more hard disk space to their network. Windows Server 2008 provides more tools than ever to manage this disk space. Before Windows Server 2008, in a lot of cases, you needed third-party tools or drivers to access this disk space. Windows Server 2008 can natively access more types of storage than ever before and provides more tools to manage the storage. This section will take you through all the different storage types and the technology used to run them. Direct Attached Storage, or DAS, is a storage system which is attached directly to one server. This is usually attached to the server through a SCSI controller or fiber cable. The advantage of DAS is that it provides a single server with very fast storage. DAS is block-based, which means data is moved as unformatted blocks between the server and the storage system. The main disadvantage with DAS is that free space from one server cannot be used by another server, as shown in this example. App 1 is almost full, while the other servers have a lot of free space. Given that DAS is directly connected to the server, there is no way that App 1 can use any of the free space from the other servers. This means that if you use DAS, you will need to make sure that you plan ahead. Network Address Storage, or NAS, is a storage system you can attach directly to your network. NAS storage devices run their own operating system and are file-based rather than block-based. Think of NAS as being like a file server. The advantage of NAS is that they are often simple to implement. The disadvantage is, since they are LAN-based, they are slower than devices directly connected to your server. Also, being file-based, NAS is a bit slower than block-based. This means it may not be a good fit for some of the servers in your organization, like database servers. NAS applications generally come with their own web-based tools to manage them. Windows Server 2008 does not provide any administration interface for NAS applications. The big advantage with NAS is that, like a normal file server, anyone can connect to it. Storage Area Network, or SAN, have become more and more popular over the last few years. SANs deliver block-based data to servers. The advantage of a SAN is that a storage system can be shared amongst many different servers. This means a large amount of space can be allocated between servers any way you see fit. Once space is allocated to one server, it is used only by that server, except in the case of clustered environments. Storage can be moved from one server to another. For example, if your server hardware crashed, you could start a new server up using the same data as the old server. From a disaster recovery point of view, SANs can be a lifesaver. SANs are fast and generally connected by fast fiber optic cables. SANs generally are not as fast as directly attached storage, but the gap is very small. The fact that you can share storage generally makes the speed difference not worth worrying about. In order to connect your system up to a SAN, you need a host bus adapter, or HBA. In large environments, HBAs are connected to a fiber switch which provides what is called the fabric. All devices that connect to the fiber switch are connected to what is called the fabric. Think of the fabric as the transport for SAN data from the SAN to the host. In a large environment, it is not uncommon for there to be multiple fiber switches. These multiple fiber switches provide redundant pathways through the fabric. In a well-designed SAN environment, a single failed device will not cause an outage. Once you have connected your server to the fabric, you need to create a logical partition on the SAN called a LUN. The LUN is presented to the server and the server will see the LUN as locally attached storage. This means that you could have a server with no local hard drives connected and booting off a SAN. As far as the server is concerned, the LUN is a locally installed hard disk and does not know the difference. Different SANs offer different options, but a lot of SANs will allow you to increase and decrease the size of the LUN after it is created, making them very, very versatile. Fiber channel is the most commonly used technology in SANs. A basic fiber setup with redundancy may look something like this. SCSI devices commonly use a shared bus to transmit data. In a SAN environment, fast switching technology is used to transmit data throughout a fiber network. In this example, there are two SANs connected to two fiber switches. Multiple paths exist between the servers, so a failure of one device will not cause all the servers to go down. The middle server has 2 HBAs, so will keep going in the event of any single device failure. Notice also that certain tape drives can also be directly connected to the SANS fabric, making backups and restores a lot faster. The main disadvantage of a fiber SAN is the high costs, and often different vendors' equipment does not work well together. This makes SANS a specialized field requiring special expertise. Since most SANs use fiber optic, a server using a SAN can be connected via fiber optic to a SAN 10 kilometers away. In large sites, there may be a backup SAN in a different building mirroring the production SAN's data. SANs also support an unlimited amount of devices. Other storage solutions like SCSI buses often limit devices to 16 and have distance limits of 25 meters. Since SANs are a block device, they can be used for high-performance servers like database servers and application servers. The long distance with fiber optic connections makes SANs a good candidate for disaster recovery. Despite the high cost, the speed and versatility of SANs are making them become more and more common. iSCSI, or Internet SCSI, helps overcome some of the high costs and lack of standards in fiber SANs. iSCSI is an industrial standard that sends SCSI commands over TCP/IP. Since iSCSI uses TCP/IP, you can use your existing network or purchase an almost endless range of network equipment that it will work with. This makes iSCSI easier and cheaper to set up. For performance reasons, I would recommend using a separate network for iSCSI where possible. iSCSI can be used over very long distances. You could have a server connected to an iSCSI device on different sides of the globe. Keep in mind that even though it is possible, I would not try and attempt to install a highly used database in this configuration. Next, iSCSI has built-in security. In a fiber network, security is performed by limiting access to the cables. Fiber optic cables are very hard to eavesdrop on, but it is possible. iSCSI uses CHAP for authentication and IPsec for security. iSCSI, however, is slower than fiber optic. If you purchase 10 GB network equipment for your iSCSI network, the performance is quite good. However, such equipment is expensive at the moment. Windows Server 2008 offers a number of tools for the management of your SAN. First, there is SMFS, which is available on Windows Server 2008 as an additional feature. The feature is added by using the Add Feature wizard in Server Manager. SMFS allows you to manage your SAN using Windows Server 2008 without the need for third-party tools. Using SMFS, you can create a new LUN, allocate storage, and discover new devices. Next, there is Storage Explorer, which is located in Administrative Tools. Storage Explorer is great for showing you what SANs are connected to your server. It will also tell you detailed information about the fabric and HBAs connected to your server. If you are planning on using iSCSI, you need to know how to use the iSCSI Initiator, which is found in Administrative Tools. This tool allows you to configure security and discovery for your iSCSI device. Using this tool, you can set your server up to connect to a presented iSCSI device on another server. Lastly, there is DiskRaid. DiskRaid is a command line tool that lets you create and manage LUNs. Using DiskRaid, you can get detailed information about your HBAs and drives. If you want to make a drive online or offline, you can do it from DiskRaid. In most cases, you'll be able to perform all your administrative needs from the tools provided by the manufacturer. The tools provided by Windows Server 2008 are very useful and they're at your fingertips. These tools provide a common interface, regardless of which manufacturer of SAN you purchase, so they are worth looking into. In Windows Server 2008, the main tool that you'll be using to manage disks is the Disk Management tool. This can be found in Computer Management in Administrative Tools. You can also run diskmgmt.msc from the Run box in the Start menu. I prefer to run Disk Management from the Run box, as this gives me a full screen view to view Disk Management in. If you access it from the Computer Management tool, Disk Management shares its real estate with the Computer Management tool. When you install a new hard disk in your system, you'll need to initialize the disk in Disk Management. Initialize Disk puts a unique signature on the hard disk. If your hard disk is removed or changed to a different controller, Disk Manager will be able to recognize the change from the signature on the hard disk. If you ever put your hard disk into another computer, Disk Management will look at the signature on the hard disk and realize the hard disk is from another computer and label it foreign hard disk. When this occurs, Disk Management will give you the option to import foreign disks so that you can use the foreign hard disk in that computer. Disk Management also allows you to bring hard drives online and take them offline. If you have any hot swap drives, you may want to take them offline before you remove them. Disk Management allows you to create volumes and format these volumes. You can even extend and shrink existing volumes. This can be a real lifesaver if you incorrectly partition your hard drive or your needs change. Previously, the only way to do this was to back up your data, reformat, and start again. Disk Management allows you to create a fault-tolerant disk set. A fault-tolerant disk set is a disk set that can have a hard disk crash and the disk set still run without any loss of data. With Disk Management, you can also create disk sets with performance in mind. These disk sets give you a speed boost, but if you lose a hard disk in the set, you lose all your data. Disk Management is a powerful tool, but before getting started with Disk Management, there are a few more basics to look at. Partitions and volumes are terms that are often seen as being interchangeable. You may hear someone say, "I installed my database on C partition," and another person say, "I installed my database on the C volume." A partition defines the low-level structure of your hard disk. The structure will create a start and end limit to what you can use. Once a partition is created, the computer is free to format the partition and create a volume. Think of partitioning as reserving part of the hard disk. When you create a volume, you are using the partition for that volume. When you create a volume, the volume will use all the space in the partition for that volume. Volumes can also use many partitions on many hard disks. This occurs when you create a disk set, which I'll cover later. Don't worry if you don't quite understand partitions and volumes. When you create a volume in Windows Server 2008, it automatically creates the partition for you. Before you can start using your new hard disk in Windows Server 2008, the hard disk needs to be initialized, which creates a partition table. The partition table defines where data is found on the hard disk. Think of partition tables like chapters in a book, and the partition table as the table of contents. In Disk Manager, there are two types of partition tables you can put on your hard disk. The older system is called Master Boot Record, or MBR. This is the most compatible option with older operating systems. With MBR, you can have 4 primary partitions per hard disk, or 3 primary partitions and 1 extended partition. What this means is that you can create a maximum of 4 partitions on your hard disk using primary partitions. If 4 is not enough, you can lose a primary partition and replace it with an extended partition. In an extended partition, you can create logical partitions, which increase the maximum number of partitions on one hard disk to 26. In the real world, unless you need more than 4 volumes on one hard disk, which is unlikely, I would not worry too much about primary and extended partitions. These partition schemes go back to the MS-DOS days. If you create the new style of partition table called GUID Partition Table, or GPT, you can create 128 primary partitions. Because the number of partitions is so high, GPT does not need or use extended partitions. Keep in mind that a volume is formatted on top of a partition, so using the GPT partition table, you could have 128 volumes on one hard disk. Why you need so many is beyond me, but GPT can do it. If you are not sure which partition table to use, I would stick with MBR. It is the older system, but it is also the most compatible. If, however, you are using a hard disk that is greater than 2 terabytes, you will need to use GPT. MBR does not support partitions greater than 2 terabytes. If you decide to use GPT, GPT does require a 64-bit system to boot off. 32-bit systems will not boot off the hard disk due to a limitation in the BIOS. Some older operating systems will not be able to read the hard disk even after boot. The 32-bit edition of Windows Server 2003 with Service Pack 1 can read a GPT hard disk. Make sure you consider any compatibility issues before you use GPT. If in doubt, use MBR. When you install a new hard disk in Windows Server 2008, you will need to initialize the hard disk. The hard disk will be created as a basic disk. Basic disks are the older and more compatible system. If you have no need to upgrade your hard disk to dynamic, then I would leave it as a basic disk. The biggest limitation with basic disks is that you can only create simple volumes on them. A simple volume can only use the space from one hard disk. Dynamic hard disks support more features. The biggest difference with dynamic disks is that you can create a disk set. With Windows Server 2008, if you attempt to create a disk set with a basic disk in it, you will be prompted to upgrade the disk to dynamic. This makes creating disk sets in Windows Server 2008 a lot easier than previous operating systems which required you to upgrade your hard disk to dynamic first. Once you upgrade your hard disk to dynamic, it will no longer work under some older operating systems like Windows NT and Windows 98. Unfortunately, once you upgrade your hard disk to dynamic, if you want to go back to basic, you will need to back up your data and reformat the hard disk. Once a partition or partitions has been created, it can be used to create a volume. In reality, when you create a volume in Windows Server 2008, it will automatically create the partition or partitions needed for that volume. The simple volume is the most basic volume that you can create. It contains a single hard disk and does not have any fault tolerance. It can be created on basic and dynamic hard disks. The simple volume occupies contiguous space on one hard disk and cannot exist on more than one hard disk. Simple volumes are just a matter of right-clicking on some free hard disk space in the disk manager and selecting New Simple Volume. Span volumes allow you to use free space on multiple hard disks and create one big volume. In the example shown, there are 3 hard disks with space on them. Using a span volume, I can create a new volume that uses all the free space from these 3 hard disks as one big volume. Span volumes cannot be used on the system and boot volume to make them bigger. However, you can make your boot or system volume bigger by expanding it if you have free space after the volume. If you create a span volume, if you lose any hard disk in the disk set, you will lose the entire disk set. Span volumes offer no redundancy. Also, span volumes lay out data from start to finish. This means that you will not see any performance gains using span volumes. Striped volumes are also known as RAID 0. Data is stored evenly across all the hard disks in the set. Since data is spread across all the disks, performance of striped sets is very fast. However, there is no fault tolerance. As you can see in the example, data is spread across all the hard disks in blocks. To read the hard disk sequentially, you simply read the blocks in order. If your file takes up blocks A, B and C, when your file is read, 3 hard disks will perform reads at the same time, making reading very fast. Writing to the disk set is equally as fast, because up to 4 hard disks in this example could be writing at the same time. If you lose a hard disk in a striped set, you lose everything in the disk set. For this reason, these disk sets are only used when performance is required and redundancy is not. Page files and temporary files are a good candidate to put on striped sets. In order to create a striped set, you need 2 or more hard disks of the same size. If your hard disks are different sizes, then Windows Server 2008 will shrink the striped set down to the size of the smallest hard disk in the set. The boot and system drives cannot be made into a striped set. If performance is all that you are after, then striped sets are a good option. Mirrored volumes, or RAID 1, provides fault tolerance by keeping 2 copies of the same data. Mirroring requires 2 hard disks of the same size. If the second hard disk is bigger than the first, the remaining hard disk space will be left as free space. Mirroring can be used for your system and boot drives. This is the only fault-tolerant solution offered by Windows Server 2008 for your operating system. If one disk fails, Windows can still use the other one. Since a copy of the data is on both hard drives, read performance is increased since the operating system can read both hard drives at the same time. Write performance is about the same. The disadvantage with mirroring is that it takes half of your disk space for redundancy. In other words, mirroring doubles the cost of your drive space. RAID 5, or otherwise known as striped set with parity, combines the disk space of 3 or more disks into one volume. The data is spread across all disks, with a single disk being allocated to parity. This means that RAID 5 has excellent read performance but poor write performance, since all disks must be accessed on each write. As shown in the diagram, one drive contains parity information which can be used to reconstruct a missing hard disk. For example, if hard disk 2 was to fail, I would lose all the data on hard disk 2. Even though I can no longer access the data on hard disk 2, I can work out what the data was from the parity information. This means my volume set will still function after I've lost one of my hard drives. If I lose 2 hard drives in the volume set, you will lose the whole RAID 5 volume. If I replace hard disk 2 with a new hard disk, the new hard disk will not have any data on it. However, using the parity information and the data on the other hard drives, I can work out what the data on hard disk 2 should be. Using RAID 5 does mean that you lose one hard drive to parity. The more hard drives in the set, the more usable space you have and the less you lose to parity. For example, if you had 3 100GB hard drives in a RAID 5 volume, this gives you 200GB of free space, losing 33% disk space to parity. If you have 600GB hard drives, you would have 500GB of free space, losing 16% to parity. You cannot make the system or boot drive into a RAID 5 volume. RAID 5 is generally used when you need a fault-tolerant solution and poor write performance is not an issue. Because you only lose one hard drive to parity, RAID 5 is widely used when cost is a factor. All the solutions offered by Windows Server 2008 are via software. This means the operating system makes all the decisions where to put the data on the drive. In order to access the data on any RAID drive in Windows Server 2008, the operating system must be booted. When you make your system or boot drive a mirror set, the computer simply boots off one hard drive, and then when the operating system loads, it can access the mirror through the operating system. This is why you can't make your system and boot drive anything other than a simple volume or a mirror set. All the other software RAID solutions require drivers before the disk set can be read. If the computer cannot read the hard drives, it cannot read the drivers. The solution offered by Windows Server 2008 is called Software RAID because they require software to make them work. However, a lot of vendors offer hardware RAID solutions. Hardware solutions are faster than software solutions. Hardware solutions can also be used on your system and boot drives. Thus, hardware RAIDs offer a way to make your system and boot drives a RAID 5 array or a stripe set. You may require additional drivers when you first install Windows Server 2008 to find the RAID array. In the Windows Server 2008 setup program, the partition screen gives you the option to load additional drivers. After you load the driver supplied by the manufacturer, you should be able to see the hardware RAID and install Windows Server 2008 onto it. The vendor that supplied your hardware RAID will also supply software to manage the RAID. In order to set up a RAID array, you need to use their software to create the RAID array. Once the RAID is created in Windows Server 2008, you will be able to see the RAID array as a single hard drive. As far as Windows Server 2008 is concerned, the hard disk is a single hard disk, and you can partition it any way you want. Traditionally, hardware RAIDs can be purchased and added to your server via an adapter or a PCI card. Software RAID was often used when the end user could not afford a hardware solution. When SATA hard drives came onto the market, a lot of motherboards started adding support for hardware RAID. If you are planning on implementing a RAID, check your motherboard to see if it supports it. Most motherboards on the market nowadays support some kind of hardware RAID. Hardware RAID also offers some different choices in RAID that Windows Server 2008 does not have. For example, RAID 0+1. RAID 0+1 is a striped set of hard drives like RAID 0 in which a mirror set is put on top. In other words, RAID 0+1 is a mirror of a striped set. RAID 0+1 is becoming more and more common in the workplace. It has good read performance and write performance and excellent recovery. If you have the choice, I would always recommend hardware RAID over software RAID. Windows Server 2008 allows you to change the size of your existing volume, making them bigger or smaller. This allows you to correct some mistakes at install time or if your needs change. Your system and boot volume can be extended into free space. However, they cannot be extended onto another hard disk. The system and boot volume can also be shrunk if you have free space available. Any files located in the area being shrunk will be moved to another part of the hard drive. Because of this, shrinking may take some time. Shrinking or extending work by moving the end of the partition either forward or backwards. In order to do this, there must be free space before or after the end of the partition, depending on which operation you are doing. If you have bad clusters on your hard drive, you may not be able to shrink or extend the volume. If your hard disk is not the system or boot volume, you can extend your hard disk onto other disks. Basically, you are turning your volume into a span volume. Extending and shrinking only work on simple or span disk sets. You cannot extend or shrink a mirrored set, striped or RAID 5 set. If you want to change the size of these sets, you need to back up your data, delete and recreate the disk set and copy your data back on again. A mount point is a folder on your hard drive that, when accessed, redirects the request to a different volume. This is the only way you can increase the space on your system or boot drive once the drive is full. Keep in mind that this is a software solution, so Windows Server 2008 must boot before you can access the mount point. In other words, you can't move your Windows directory to another hard disk and replace it with a mount point. All of the different volumes looked at so far are configured through disk management. The information presented so far is a lot to take in. Let's have a look at disk management in action. This will help you better understand how disks in Windows Server 2008 work. You can open disk management through the computer management under administrative tools. However, I am going to run it from the Start Run box by typing in diskmgmt.msc. Running disk management in this way allows me to maximize the disk management window to use the full screen. I have a total of 4 hard disks in this system. 3 are offline. Before I can start using these hard drives, I need to switch them online. To do this, right-click a drive and select Online. You can also make a drive offline by doing this. Since these are new hard disks, they must be initialized before they can be used. Right-click on the drive and select the option Initialize Disk. I am now given the option for the type of partition table that I want to use. MBR is the older system and will give you the most compatibility. If you need to create a new partition on the hard disk that is greater than 2 terabytes, you will need to select the option GPT. GPT requires a 64-bit BIOS to boot off. I will select MBR for disk 1. Now I will bring disk 2 and disk 3 online and initialize both of these drives together. I will, however, select GPT for these drives. As you can see, the choice of partition table is irrelevant when creating volumes on. If I select disk 0, you can see I have the option to convert it to a dynamic disk. Basic disks are compatible with older operating systems like Windows NT and Windows 98. The disk will need to be converted to dynamic if you want to put the hard disk into a disk set. Don't worry too much about this. If you attempt to perform an operation that requires a dynamic disk, Windows Server 2008 will prompt you to upgrade the disk to dynamic. Previous versions of Windows required you to perform this step yourself. Windows Server 2008 makes the process a lot easier. If I right-click on the C drive, you can see that this drive can be shrunk even though it contains the boot and system files. I will shrink this drive down to half the original size. If you have a lot of files at the end of the partition, this operation could take a long time to complete. Any files at the end of the drive will need to be moved to the start of the hard disk before the drive can be shrunk. If I right-click on the drive again, you can see that I can now extend the volume. This is because there is free space at the end of the partition. I will now select Extend Drive. Notice that there are no additional drives available to extend on. This is because this drive contains the system and boot files and cannot be extended onto another hard disk. If I right click on the C drive, you can see the option Add Mirror. Add Mirror is grayed out. This is because there is no hard drive on the system that is the same size or bigger than the C drive to mirror onto. Even though disk 1 is reported as the same size, it is slightly smaller, and thus I cannot make a mirror onto this drive. In order to create a mirror for drive C, I am going to have to shrink the drive down again so it will fit on another hard disk. I will shrink the volume down to 50% of its original size. This will allow it to fit onto another drive. Now if I right click on drive C, I can add a mirror. All I need to do is select the disk to put the mirror onto. A warning message will appear telling me that the disk will need to be converted to a dynamic disk to continue. Once the hard disk is upgraded to dynamic, it will not be able to be read by some older operating systems. A mirror drive is now created for drive C using disk 1. You can see now that I have 4 disks with free space on them. If I right click on the free space on disk 0, you can see I now have the options for simple, spanned, striped, mirror and RAID 5 volumes. I want to use all the free space on all the free hard drives, so I will select one new span volume. With new span volume, I can add all the hard disks into one big volume set. This makes best use of the space. However, does not provide any performance improvements or fault tolerance. All this new space will appear in Windows as one logical hard drive, drive E. Make sure that when you format the drive, you perform a quick format. Otherwise you'll be waiting a long time for the drive to format. The only time I perform a slow format is when I think there may be bad sectors on the hard drive. If this is the case, you should consider replacing your hard disk. Again, I will be asked if I want to upgrade the hard disk to dynamic. As you can see here, I now have an E drive that is using all the free space from all the hard drives. Notice that Windows reports this drive as having no fault tolerance. This means if any hard disk in the disk set goes bad, I will lose all the data in the disk set. Span disks have no performance improvement, so I am going to delete the span disk set and create a new striped volume. Striped volumes spread the data out evenly across all the hard drives in the disk set, so this gives you a performance boost when reading and writing. The procedure is much the same as a span volume. Right-click on the unused disk space and select New Striped Volume. You will notice that the amount of disk space is 60 GB, but when I add a smaller disk, the space drops to around 30 GB. All hard disks in a striped volume must be the same size. Thus, when I create one using hard disks with different amounts of disk space, the disk set will be read as a multiple of the hard disk with the smallest amount of space. Again, I will format this new hard disk with Quick Format. Press OK again to upgrade the hard disk to dynamic. The new volume is created as E drive. Notice that the space is equally allocated across all the 4 hard disks. Notice that the striped volume appears as drive E, one single drive with no fault tolerance. Special volumes like these cannot be extended or shrunk. When I right-click on the striped drive, you will notice that these options are not available. If I delete this volume, I can now create a RAID 5 volume. This is done the same way as before. Notice that the RAID 5 volume will again be a multiple of the hard disk with the least amount of space. Again, I will format this drive with a quick format and upgrade the hard disk to a dynamic disk. You cannot extend a drive that contains the boot or system files to another hard disk. If you run out of space on your system or boot drive, you can, however, mount another hard drive to the volume as long as the system and boot files do not move. This will give you more free space on your C drive. Mounting allows you to mount a volume of any type. First of all, I need to create a folder to mount the volume to. I will create this folder on drive C called More Space. Now to mount the drive, I right-click on the RAID 5 volume and select the option Change Drive Letter and Paths. If I press the Change button, you will notice that the option for mounting the drive is grayed out. To mount the drive, I first need to remove the drive letter, so I will do this by pressing the Remove option. If I select the option Change Drive Letter and Paths again, I can now press the Add button to browse the C:/More Space. The RAID 5 volume will now be available under C:/More Space. This is the only way you can increase the space on your system or boot drive. If you have a failure on your mirror drive, you'll want to remove the failed drive and replace it. To do this, you need to break the mirror. To do this, right-click the mirror drive and select Break Mirror. Press Yes at the warning message and the mirror will be broken, allowing you to create a new one. In this case, I got an error message because both of the hard disks are still present and working. To remove the mirror, I need to select the option Remove Mirror. This will remove the mirror drive and allow me to reallocate the space. If one of the hard disks in your mirror set crashes, use the Break Mirror command to break the mirror. Once the mirror is broken, you can create a new mirror using the newly installed hard disk. That's it for disk management. You will find that once you start using disk management, it is both powerful and